Okay, good morning, class. You are welcome to the natural science class. Today we'll be looking about atoms, which is still a topic under introduction to the periodic table that we started last week. All right, my details are here. All right, I just want us to look at a summary of what we were doing yesterday. So, it is said that all matter is made up of what? Particles whose properties determine what we see or what we observe. All right. So matter, if we look at the diagram here, the mind map, you can see that matter is made up of what? Particles. And atoms are also made up of what? Smallest particles. So from the top there, atoms will come together to give you molecules. Atoms will also lose or gain electrons to become what? Ions, or to form ions. And then if an atom gains an electron, it becomes an anion. Then if an electron loses, it becomes a cation or cation. Now, what happens is that if one atom reacts with another atom, we get what? Molecules. All right. Now let's come under. You will see that all matter can be categorized or classified into two. We have got pure substances, and then we have got what? Mixtures. And then when we look at pure substances are further divided into two. We have got elements, and we have got what? Compounds. Now, when we go further, we can also say that mixtures are also divided into two. They are homogeneous and then what? Heterogeneous. Then when we go further, elements can also be classified into three. We have got metals, we have got non-metals, and we have got what? Semi-metals or metalloids. All right. So that is just the summary for yesterday. Now let's look at what we will be doing today, the lesson objectives. By the end of the lesson, we should be able to define a compound. We should know that mixtures and compounds can also be combined together. We should also know that when mixtures and compounds are mixed together, they can be separated from each other. We should also understand the concept of what? The particle model of matter, or the particle model of matter. All right. So let's look at compounds. A compound is a material that consists of two atoms, that consists of atoms of two or more different elements chemically combined together. An example is water, carbon dioxide, and sodium chloride. So I repeat again, a compound is a substance that consists of two or more different elements, or we can even say material that are what? Chemically combined. Now, if we compare this to mixtures, you remember we said a mixture is a combination of two or more substances, or we can simply say it's a physical combination of two or more substances. Now let's continue. The atoms in a given compound are always combined or bonded in a fixed ratio, such as in water, where the ratio is always two hydrogen atoms reacting with what? One oxygen atom. So if you look at the symbol, the chemical formula for water is H2O. It means we have got two atoms of what? Hydrogen, and then one atom of oxygen. So that is a fixed ratio. So it's 2:1. So if you see any compound and the atoms of hydrogen is not two and oxygen is not one, then it's a different thing else. It's no longer a what? Water. So the atoms in a given compound are always what? Combined, and they are in a fixed ratio. We can look at sodium chloride. So we have got one atom of sodium and one atom of what? Chlorine. So we can see the ratio is what? 1:1. We can also look at what? Carbon dioxide. And here we have got one atom of carbon and two atoms of what? Oxygen. So we can say the ratio is what? 1:2. Okay, let's go to the third bullet. A chemical bond is the force that holds atoms together. So what it means is that if I have one atom reacting with another atom, so let me be specific. If I have got two atoms of hydrogen, then giving me a molecule, then the bond, what is holding them is a chemical bond. And remember, a chemical bond can either be what? A covalent bond, an ionic bond, or a metallic bond. You will get to know those things as you go further. All right. Compounds such as water, H2O, carbon dioxide, CO2, salt, sodium chloride are formed by chemical reactions. So what do we mean by that? In a chemical reaction, at the end of the day, the component of the substances will change. They will not retain their individual properties or their original properties. They will change because there is a chemical reaction. Let's go to the last bullet. Compounds can be broken down in a decomposition reaction into other compounds or their original elements by heating or electrolysis. For example, electrolysis decomposes water. So H2O to form hydrogen and oxygen. All right. So we said a compound can be broken down. It means a compound can be separated using what? Heating or electrolysis. So when you see water is H2O, we can decompose it or break it down to what? H2O. We can break it down into what? Hydrogen and oxygen. So I repeat, I said water, which is H2O, can be broken down into what? H and O, which is hydrogen and oxygen. Okay, let's go to the bullets. Now we are going to look at the concept of particle model of matter. Okay. The concept of the particle model of matter. Now we are going to see how is the model of matter. You remember we said matter is made up of what? Matter can exist in what? 3 states. We have got solid, we have got liquid, and we have got what? Gas. So we are looking at what is making them. What particles? How are they related? If we look at water molecule, how are the particles related or joined together? If we look at solid particles or solid matter, how are the substances joined together, as well as what? Gases. Okay. Atoms and molecules are referred to as what? Particles in the particle model of matter. So don't forget, atoms and molecules are referred to as particles in the particle model of matter. Now let's go. What is the particle model? The particle model of matter is a scientific theory used to explain that all matter, that is solid, liquid, and gases, is made up of what? Particles. So the first thing you hear of the particle model of matter, then what comes to your mind is that all matter is made up of what? Particles. Either is solid, liquid, sorry, or gases is made up of what? Particles. So let's go on. Bullet 3, bullet 4. These particles are too small to see. In a drop of water, there will be many millions of water particles. The spaces between the particles are empty. Scientists have evidence that suggests that the particles are arranged differently in a solid, liquid, and a gas. So because these ones are different, then they will also their arrangement will also be different. Okay, let's continue with the topic. We are now going to look at what mixtures of elements and compounds. Now, you remember we described mixtures as a combination of what? Two or more atoms physically combined. And a compound is a material that consists of what? Atoms of two or more different elements, chemically bonded. An example is water and carbon dioxide, which is what? CO2. Now, elements and compounds are often mixed together, such as in air, seawater, rocks, and in living things. I repeat again, elements and compounds are often found mixed together, such as in air, seawater, rocks, and in living things. Now, for example, if we look at air, we know that carbon dioxide is a compound, but is also mixed up with what? Oxygen, nitrogen, dust particles, and other substances. Okay, so when we talk of mixtures of elements and compounds, what we are simply saying is that mixtures and compounds can be mixed together. All right, mixtures are separated by what? Physical means. Compounds can be separated by what? Chemical means. So this is another difference. So this is a point to take note of when you are looking at what? Differences between mixtures and compounds. All right, so what is a mixture? Or what one difference can we give? We can say a mixture can be separated by physical means, whereas compounds can be separated by what? Chemical means. All right. Now let's go further. I have a table here, table of common compounds. So these are examples of what? Compounds. So what we need to know is that we should be able to define a compound. We should be able to give what? Examples of compounds. So I repeat again, a compound is the combination of two or more substances that are chemically combined. So I have with me a table. As you can see, we have the formula, the chemical name, and the common name. So let's take note. Let's look at the first one, H2O. What is the chemical name? The chemical name is hydrogen oxide, but the common name is water. So when you are testing, you say, please give me water. You can equally say, give me hydrogen oxide, which is water. Now let's look at what? CO2, which is carbon dioxide. That is the chemical name, and the common name is what? Carbon dioxide. So here, the chemical name and then the common name for CO2 are the same. All right, let's look at the third one. Is NH3, which is called hydrogen nitride. That is the chemical name, and the common name is ammonia. Let's look at hydrogen chloride, HCl. Remember, is the swimming pool acid. We came across it when we were looking at substances. So the chemical name is what? Hydrogen chloride, and the common name is hydrochloric acid. Let's look at H2SO4. The chemical name is hydrogen sulfate, and then the common name is what? Sulfuric acid. And then this one is found in what? Car batteries. So take note. All right, so we have got HNO3, The chemical name is hydrogen nitrate, and then the common name is nitric acid. We have H2CO3. The chemical name is hydrogen carbonate, and the common name is carbonic acid. So remember, this is the only mineral acid that is what? Weak acid. Most of the what? Mineral acids are very concentrated, like the hydrochloric acid, nitric acid. Okay. Now let's look at sodium chloride. No, let's look at CH2COOH. The chemical name is ethanoic acid, and the common name is vinegar or vinegar. Now, when you go and buy your spatula or your cutter, sometimes you see that you have to sprinkle this acid there so that it will neutralize. The reason why you are doing it will neutralize the other substances that are already there. Now let's look at NaCl. We have sodium chloride. That is the chemical name, and the common name is table salt. I don't know whether the Litwai, I don't know whether it's Spady or Sindebele. Okay, but which of them? Litwai is the local name for sodium chloride, or the common name is table salt. Now let's look at sodium oxide, uh, sodium hydroxide, NaOH. So chemical name is sodium hydroxide, and the common name is caustic soda. Now I'll just look at NaHCO3, sodium hydrogen carbonate, and then the what? The common name is what? Baking soda or bicarbonate of soda. You remember when they are going to prepare these fat cooks, I mean cakes, what they do is that they will have to add what? Baking soda. All right. The rest I will leave them to you so that you can just go through. So let's continue. Now we're still looking at the particle model. Now, what the particle model is saying is that in solids, the particles are closely what? Arranged. In solids, the particles are closely packed, or they are arranged in a regular manner. So that's what the particle model is saying. In solids, the particles are closely packed in a regular arrangement. Let's go on to bullet 2. Bullet 3, do not move around but vibrate against each other. So what it means is that in solids, the particles do not move around. They vibrate against each other. So that's why a stone is different from what? A liquid or water. Let's go to the next bullet. Bullet 4, they have got strong forces holding them together. And the last bullet have small spaces between them. Okay, so what we have just looked at is talking about what? The concept of what? Particle model of matter. So it says that in a solid, the particles are closely arranged. The particles do not move about, but they vibrate against each other. They have got strong forces holding them together. And then they have got what? Small spaces between them. Okay. Now let's look at what the particle model is also saying about liquids. It says that in liquid, the particles are loosely arranged. They are loosely arranged, but still quite close. So what it means is that in solids, the particles are very close. In liquids, they are loosely close. And in gases, they are sparsely close. Okay, so let's move on. The liquids can move quite fast and slide past each other. Yeah, so that is why when you pour liquid on the floor, it flows. So the particles can move quite fast and slide past each other. Okay, let's go to the next bullet. they have got weaker forces between them. So if I look at the solid and then the liquid, the forces of attraction between the particles are weaker in liquids as compared to what? Solids. Okay, let's continue. They have got what? Small spaces between them. Okay, all right, let's go to the next. All right, we're looking at gases. So what is the particle model talking about or saying about gases? One, in gases, the particles have no particular arrangement. In gases, the particles have no particular arrangement. They move very fast, have extremely weak forces between them. So that is why when you are at the other side of the room and you spray a perfume, somebody who is a bit far away but the same room or in the same house will what? Will get the smell of your what? Your perfume. So that is what they are saying. They move very fast. And because they move very fast, it tells us that the particles are weak. Okay, let's go on. They have got very big spaces between them compared to what? Solids and liquids. So if we're going to say in terms of kilometers, in gases, they can be what? 20 kilometers between the particles. In liquids, let's say they can be 10 kilometers. And in solids, let's say even 5 kilometers between the particles. I'm just giving you a fair idea. So now let's go on. So we know what the particle model is talking about, the various states of matter, solids, liquid, and what? Gases. Now let's go on. Diffusion is a process in which particles in liquids and gases move from a highly concentrated area to an area with a lower concentration of those particles. So as I was saying, if you stand in one corner of the house or the room and spray, then what you are going to feel is that at the other side of the room, a bit distance away, you are going to what? Experience or smell the perfume or deodorant. Now, the process of these particles moving from one place to another is diffusing. So where you stood and you sprayed, that place, the particles of the deodorant or perfume are concentrating. There are so many there. Then, because there are so many, they will begin to move away to places where the particles are not. So that's what we are saying. They move from a region of higher concentration to a region of what? Lower concentration. Okay, now diffusing is faster in gases compared to what? Liquids. So what we are saying is that diffusing is faster in gases. So gases diffuse faster compared to liquids and compared to what? Solids. In fact, solids cannot move. So we mostly compare gases and liquids. Okay. Now let's look at the properties of states of matter. So this table summarizes all what we have just spoken about. So we have got properties of states of matter. We have got solid, we have got liquid. Now let's look at the particle diagram. So you see that the particles of the solid are so closed. Now look at that of liquid. They are close but not as compared to what? Solid. And then just see that of gases. They are almost escaping. Now let's look at the volume. So for example, if I have a stone, the stone is fixed, the volume is fixed. Let's look at liquid, the volume is definite. Now let's look at the shape. They don't have a shape or volume. They mostly expand to fill the what? The container. Now let's look at the shape of them. Solids have a fixed shape. So if I have a stone, the stone is fixed, it's having a fixed shape. Now, if water don't have a shape, but if I pour it into a container, they can take the shape of the container. Okay, so the same gases do not have shape or volume. They expand to fill. Now let's look at the spaces between the particles. You see that they are touching each other. These ones are also touching each other, but they still be further apart. Then the gases are even more further apart. Let's look at forces between the particles. They ask for the forces between the solids are strong, liquids are medium, and then gases are what? Very weak. Now let's look at arrangement of particles. They are close together. They have got a fixed position in a set pattern. Now let's look at the arrangement for liquids. Random. They don't have a fixed pattern. Gases are just on their own. Now let's look at the movement of the particles. Vibrate about their positions. Liquids slide past each other and switching places, and they are very fast and free. Okay, I can see that most of you are sending me so many questions. Okay, all right. Now let's go on. Okay, it's now your turn. It's your turn now to. It's your turn now to answer the following questions. So you are going to study this diagram below and identify which one is a gas, solid, or liquid. Yes. So this is how you should answer. So you say I, if I is liquid, you write I is liquid. If I is what? Also liquid, you write. If I is also what? Gas, you write. So let's get busy through the what? The chat room. Guys, I want you to answer them together. If you give your answer before you post. Make sure that you give the answer for I, the answer for the answer for I, and then you post. Very good. I like the way Megan is doing it. Yes, Megan, you are listening very well, but take note of your spelling. Yes, that's good. Yeah, yeah, keep your answers coming. I can see that you are getting 3 out of 3, most of you, but those of you who are sending only one, you are getting 1 out of 3. Yes, send in, then we go on. Yeah, 100%. You got 3 out of 3. So if you send, I mark you 3 out of 3. Yeah, 3 out of 3, that is correct. All right, the next minute we will move to the next slide. Yes, 3 out of 3. Yeah, 3 out of 3. That's correct. All right, that's good. I like the way you are responding as always. Let's go to the next slide. Let's go to the next slide. Okay, the next slide is talking about what? So from the top here, I will say question 2 and question 3. So I want you to give examples. So what I want you to do, you write, we just finished looking at question 1. So I forgot to give my, yeah. So this one is question 2. Question 2 is saying, write 2 examples of what? A compound. So if you send me one, you will get 1 out of 2. I want all of you to score to get 2 out of 2. So let's go on. Let's go on. You give me the what? The different 2 examples. I want you to give me 2 examples of what? Compound. So let's go on. Send in your answers. Send me your answers for question 2 before we then go in for question what? 3. Okay, I said question from the top, we are talking about what? Question 2. And the question is saying, write 2 examples of a compound. So I'm saying you must give all your 2 examples so that you can get all your what? 2 out of 2. Okay, before we go to, yes, that's correct. Yeah, 2 out of 2. Yeah, 2 out of 2. That's perfect. 2 out of 2. Perfect. So also 2 out of 2. That is correct. And Tiamo, check the formula for water. Check the formula you're spelling. Okay. All right. Yeah, this is also correct. You're getting 2 out of 2 also. Out of 2. Okay. All right. Kia, you are also correct. Yeah. That is 2 out of 2. Okay. Yeah, every day we are improving. Okay, that's great. All right, now let's go to the last question. The last question is saying differentiate between what? A mixture and a what? A compound. So let me give you a clue. So when we're talking about what differences, you can use the definitions to give difference. You can also give examples. You can also use how their ratios. You can also use their ratios to what? Give an example. Okay, so what do I mean by ratios? A compound. All right, some people are already sending in mixture is 2 or more things mixed together. Compounds has nothing mixed with it. Uh-uh. Yes, I said make sure that you give your difference in a what? A sentence. Yes. Tiamo, why are you lost? Ask your question so that I will explain. All right, guys, let's keep pushing. All right. Okay, complete it. Yes. All right, yeah. Okay, guys, you have all done very well. Okay, the time is, yeah, the time is almost finished. All right, so let's try to finish the next slide and then we will go on. All right, so let's look at our answers. These are the corrections. Yes, so number 1, almost all of you got it correct. I is a solid. II is what? Liquid, and II was a gas. Yeah, so in exams, they can give you the particles, the way the particles are arranged, and ask you to do what? To identify them. Now, an example is we can say water and sodium chloride. And then number 3 was saying we should give a difference between what? Mixture and a compound. So you can say mixture is when two or more substances are physically combined. Then it means you can simply separate them by what? Using physical methods, if you remember the methods we did. Then a compound is when two or more substances are what? Chemically combined. So these are the corrections for our class activity that we just did. All right. Now, so let's look at the summary of the lesson. So far, we have been looking at a compounds, and we said a compound is a material that consists of what? Two or more that consists of two or more different elements, chemical bonded together. So water is an example, carbon dioxide and sodium chloride. So we also said the atoms in a given compound are always combined in a fixed ratio. An example is in water, in which the ratio is 2:1. So we said a chemical bond is the force that holds atoms together. So an example of compounds are water, carbon dioxide, sodium chloride, and we should remember that they are formed during a chemical reaction. Okay, we said compounds can be broken down or they can be separated using what? Decomposition reaction. Decomposition reaction means to break down. Okay, so for example, if we want to break down water, we have to use this electrolysis, in which we can separate hydrogen and oxygen. All right. We also look at what? Mixtures of elements and compounds. So what we are simply saying is that we're saying elements and compounds are often found mixed together, such as in air, seawater, rocks, and what? Living things. So we say mixtures are separated by physical means. Compounds can be what? Separated by what? Chemical means. Then we looked at what? The concept of the particle model of matter. So we're saying atoms and molecules are referred to as what? Particles in the particle model of matter. The particle model of matter is a scientific theory used to explain that all matter, that is solid, liquid, and gases, is made up of what? Particles. So even the shirt you are wearing, the phone you are using, the pen you are using to write, they are all made up of what? Particles. So we're saying these particles are too small to see. So for example, in a droplet of water, there can be many billions of water particles. That is correct. And then we said the spaces between the particles are always empty. And then we said scientists have evidence that suggests that the particles are arranged differently in solid, liquid, and a gas. Yes. So that is what we just did. The activity 1 is supporting what the last bullet is saying. Scientists have evidence that suggests that the particles are arranged differently in a solid, liquid, and what? A gas. So you saw that the solid particles, in solid, the particles are close. In liquids, they are not that close. They are, even though they are close, but not compared to what? That of solid. And in gases, then they are not very close. They are sparsely related, or they are far apart. Okay. All right. So this is a link. If you can go through to access this book for Siavula. All right. So grade 7 natural science. Okay. All right. Our next lesson, we will continue with the concept of what? Particle model of matter. And if you want to follow the lockdown using social media, you can also do that. Okay. It was nice time having you guys. I hope to see you. I hope to see you tomorrow again. All right. Bye for